Hello everybody, welcome back to Mathlete's Corner. In this video, we're continuing with absolute values level 2. So we have one really nice AMC 10 problem and one really nice AMC 12 problem. So let's get right into it. Our first problem is the 2021 AMC 10A problem 19. And essentially all we have to do for this problem is find the area of the region bounded by this graph. And we don't like those sneaky absolute values on the right hand side. We can notice that this is really similar to the graphing question we did in the last video, and we can kind of take a similar approach to that. And if you don't remember, what we did is we said if the point x comma y, if we know that is on the graph, what other points do we know are on the graph? Well, we know we have negative x comma negative y, and why is that? Because these squares stay the same, and x minus y becomes y minus x, same absolute value. X plus y becomes minus x minus y, again, same absolute value. Similarly, we can also say x comma negative y and y comma negative x are both on the graph. So what do we get out of this? Well, we know that our graph will be symmetrical. And so instead of looking at four cases, we can just look at one and multiply by 4. So we're going to do exactly that. So we'll put times 4 here so that we remember at the very end to multiply by 4. And we can take one of our scenarios. So let's say x minus y and x plus y are both positive. And if we have that, we just get the equation x squared plus y squared equals 3 times x minus y plus 3 times x plus y. Now that just simplifies to x squared plus y squared equals 6x. Moving everything to one side, we get x squared minus 6x plus y squared equals 0. We see this, we know what to do. We just have to complete the square. So when we do that, we get x minus 3 whole squared plus y squared equals 9. And that's the equation of a circle. So now that we know what shape we're graphing, let's actually graph it. And remember, we're only looking at this region here. It's the region we want. Now we know our circle is centered at 3 comma 0, so that's right about there. And we know the radius of our circle is also 3. So we get this kind of shape. And I didn't draw the whole circle because, as I said, we're only looking at this quarter of our coordinate plane. So what we get is that in our section. Now for the other sections, we'll get something very similar, likely something looking like this, right? Because of that symmetry. Now all we have to do is find what's the area. Well, we know that the diameter of this is 6 because the radius is 3. So the square has an area of 36. Or maybe I'll write that on the outside just for more neatness. And we know the radius, as I said, the radius is 3. And if we put the 4 semicircles together, we get 2 circles, each of radius 3. That's 9 pi plus 9 pi. That's 18 pi. So now that we have our total area, 36 plus 18 pi, we can go back to the question. They're asking what's m plus n, so we have to do 36 plus 18, and that comes out to 54. That's our answer. Now, on to the next question. The next question is the 2023 AMC 12A problem 16. And it says, consider the set of complex numbers z satisfying the absolute value of 1 plus z squared equals 4. Let's stop right there. We have the absolute value of a complex number. What is that? We haven't defined that. So if we recall our definition from the last video, I said the absolute value of a is distance from a to 0. Well, how do we find the distance from a complex number to 0? And that is where we continue our graphing. So if we were to graph a complex number, say it's here, this is a plus bi. Now, what's the distance from that to 0? Well, where's 0? And 0 is just 0 plus 0i, so that's just the origin. Now, what's the distance from here to the origin? That we know from the Pythagorean theorem. That's just square root of a squared plus b squared. So now we've defined the absolute value of a complex number, and we can continue reading. The maximum value of the imaginary part of z can be written in the form square root of m over n, where m and n are relatively prime positive integers. What's m plus n? Now, this is a funky quadratic. So what we're going to do, we're going to take that and we're going to say, hey, it's equal to our constant c. And c has an absolute value of 4. That's what the question says. Now, if we just move everything to one side, we get a quadratic in z, and that's equal to 0. Now, let's try the quadratic formula, see what happens. We get z equals -1 plus or minus the square root of 1 minus 4 times 1 minus c all over 2. Now, this we can do the algebra off here on the side. We get 4 minus 4c, and that's 4c minus 3. So now we know the discriminant here is just 4c minus 3. Now, if we go back to the question, we have to remember the question is asking for the maximum value of the imaginary part of z. So, in other words, that means we don't care about the real part. So we can actually get rid of the real part here. And let's actually keep the plus or minus because that could still be a part of the imaginary part of z. Now, all we want now is the maximum possible imaginary part of this. This is still not very neat, not really something we know how to work with. So let's go back into the idea of graphing. So what are we going to graph? Let's graph 4c minus 3. We know that the absolute value of c is 4, so the absolute value of 4c has to be 16. So that would just be a circle centered at the origin of radius 16. Now we do have that minus 3, so we'll shift it 3 units left. When we do that, we get something like this. Yes, that's supposed to be a circle. It's centered here at -3 comma 0, and it has a radius of 16. So I'll put -19 comma 0 here, and I'll put 13 comma 0 right there. Now, how do we take the square root? Well, when we have a complex number and we square it, what we do is we take the magnitude and square the magnitude. We take the angle and we double the angle. And by angle, I mean the angle to the positive x-axis. So if I was to square this, I would square the magnitude, double the angle. It would go somewhere out there. Now, if we were to do square root, we would just do the opposite. So we would take our complex number, we would take the square root of the magnitude, and we would half the angle. Now, which of the points on this circle will give us a square root with maximum possible imaginary part? Well, we know that this is at 180 degrees. So if we were to take the square root of that, it would go to 90 degrees. And 90 degrees is obviously the maximum y value. But how do we know that none of the other points have a higher y value? Well, that's because this point is clearly the furthest from the origin. So it has the highest magnitude, and all of that magnitude is going into the y value. So we know that this is the point that we're looking for. This point is not c. This point is 4c minus 3, and we know this is equal to -19. Now, if we just do the algebra, we get 4c equals -16, and c is equal to -4. Now, we can plug that back in here. We get plus or minus the square root of -19 all over 2. We get plus or minus I root 19 over 2. Obviously, we want the plus since we've been maximizing this whole problem. So our final answer would be root 19 over 2. We go back to the question, it says, what is m plus n? So that's basically 19 plus 2. Comes out to 21, and that's our final answer. That's all for this video. Thank you for watching. Don't forget to hit that like and subscribe button, and we'll see you next time here at Mathlete's Corner.